This conference will now be recorded.
Okay, so hello everybody. So I'm Brian Paynter. As Gilles says, I'm the program director for Track in Wales and Western, and I flicked through the names that have dialed in today as we were waiting, and I know quite a lot of you, and there's quite a few people actually that are on the call that were involved in this job. Now I'm slightly out of my comfort zone in terms of the job because actually this isn't one of my jobs. But hopefully you'll realise why I'm presenting this today. But I have spoken to my opposite number from Buildings and Civils in Mike, and he knows I'm doing this brief today. So my background, for those of you who don't know me, this is my 34th year in the industry. Started my life as a PWA technician, PWA engineer, back all those years ago, doing survey, design, planning, and delivering track renewal projects, and ended up delivering track renewal projects all over the UK. So yeah, and then I moved into project management, and now I'm in a leadership role. So why was I involved at Gypsy? I was involved at Gypsy because the job has been very, very publicly known that the job was in trouble. Now, the job was actually designed to actually be delivered earlier in the year, but it got delayed. It was one of the casualties of COVID earlier on in the year, so the job did get delayed by around 6 months. And I guess the highlight, the kind of headline is, one of the headlines is, we'll never really know if that job had been delivered when it was supposed to be delivered. We'll never know if we would have had the problems that we ended up having when the job was delivered, ultimately back about, well, just over a year ago now. So I was asked to get involved to help with seeing if there was any time in the plan, because the job was running quite far behind when I was asked to kind of go to site on the Monday. And my challenge was, in the OLE signalling and track plan, is there any recoverable time such that the impact we have on our customers is reduced to the kind of the forecast that was already being presented, which was going to be a significant overrun. Now, again, if it had happened, if COVID wasn't here and we'd had this problem, then the impact would have been even more significant, because the Buildings and Civils team were delivering this work during kind of lockdown times. So there weren't many people traveling on trains, and the train service was thinned out anyway. So the overrun was less of an impact, but it still was an impact because we did overrun by a couple of weeks. So I spent, when asked to go over there and just take a look, I then spent nearly every day there for quite a number of hours every day for about 3 weeks. And in a strange kind of way, I actually enjoyed it, because it gave me 3 weeks out of track, albeit there was quite a significant amount of track involved in this work. But it gave me 3 weeks actually to look at somebody else's work, and actually I took some lessons away, which we will come to as we go through the slides today. So, don't know why the slide isn't moving on, but it is moving on. You just have to bear with me a sec, because for some reason the slide, there you go. Right, that's okay, sorted it. And actually, this was a question from Sarah the other day, worrying about, oh my goodness, I spelt it wrong. So if you look on the previous slide, it's Gypsy with an I. If you look on this, and that's what Gypsy Patch Lane is spelt as on the road sign. But then if you go up on the bridge, it's spelt as Gypsy Patch Bridge. Either is acceptable. So if you do see it spelt in different ways, not a concern. So I guess one of the reasons for me putting this slide up was, apart from that bit, was this was more than just a bridge. And I kind of ask you to just, whilst I've got this slide on the screen, is take a look at the complexities that you can see in front of you there. You can just about see the parapet units that have been installed on the right hand side of that picture, but just spot the complexities. And there is an additional complexity which you might not be, well, you certainly won't be able to see from this picture, but you will see later on. But there's a whole load of things on this structure that I would have expected that as a capital delivery team in Wales and Western, we would have reached out to each other. So somebody could have reached out to me in track, because this was a complex piece of track on top of a complex structure with OLE. There's enough of us around that could have perhaps reviewed this job a little bit more than actually did happen as part of the normal process. So as I said at the start, had it not been for COVID, this overrun may never have happened, and I'll come to the reasons by that. I've talked about the fact that this was delayed by 6 months. I've talked about the fact that it overran by 2 weeks, but the weather played a significant factor in this. So just what I wanted to cover on this today was I'm going to take you through a very high level. I will cover some of the slides in this pack of mine, and some of the slides are the slides that came from the lessons learned. And there was a team set up to complete the lessons learned, and I've noted through the names that are on the call today, including myself. I was asked to be part of that lessons learned exercise, as were quite a few of the people on the call that I've seen at the start. So I'm going to talk about feedback from lessons learned, and then I just want a kind of general discussion, because some of the things that I say might be a little bit subjective, and rather than me say this is how it should be, I want to debate some of those points, and I'll come to those later on in the presentation. So for those of you who don't know where Gypsy Patch actually is, what you can see on this slide now is a map of Bristol, or at least a map of outer Bristol. So you can see Bristol Parkway on there, which is the mainline station. You can see Patchway Station, which is the station that takes some of the local stopping services in and around into South Wales. And it's a key route. This is a key route for the region, because it does, the main thing that it does, what Gypsy Patch does, is takes people from South Wales through to London. So it's part of that diamond of track you can see there. The red arrow is pointed to exactly where this job was, just slightly towards Bristol Parkway from where that arrow is the Hitachi depot. So again, another key interface for this project, and there's a lot of S&C around this structure. So as I said in that earlier slide, this was made more complex because of what was actually on the structure as well. So the summary, so if you read this made me chuckle the other day. I did make this slide myself. This made me chuckle because what it says is Gypsy Patch Lane in Littlestoke will be closed for almost 2 years for the removal of a railway bridge. Well, the important part was actually we were putting one back as well, because if we just removed it, obviously it might help the locals. And those of you who know this location will know that it is a little bit of a rat run for people who like taking shortcuts around Bristol. But equally, it gets very, very congested, and that is the structure in the background you can see there that was being replaced. And this is an artist's impression of what you've kind of now nearly got. It's not quite there yet in terms of being fully open, but this is an artist's impression of what was going to be there in the future. And then that there is a picture to kind of put it into kind of scale. Is those two pictures have been scaled to size, and the one obviously at the top is what was coming out, and the one at the bottom is what was going to be put in. And what you can see underneath the structure there, and I'll refer to these a fair bit through the presentation, is the SPMTs, which were the transporters that lift the bridge from its build location into its final location, which I can touch upon on this slide here. And what you see in this slide is on the left-hand side is an aerial photograph of where the bridge was built, and it was built in readiness for being installed back in the April. But it didn't move back in the April, as I said, because of resourcing issues due to COVID. And then what you can see there with the end of that arrow is where the bridge was moved to initially, and then it failed. And then what we'll talk about through these slides, and I'll cover in high level, is the bridge failed because of what you can see in that photograph on the bottom right-hand corner. In fact, if you look at the top photograph, top right, you can see ground conditions which are quite wet, And then what you can see in the bottom right-hand photograph is the wheels of the SPMTs, which are carrying this just short of 5,000 ton load, basically being stuck in the, I won't call it mud, but it resembles mud, but stuck in the type 1 fill, compacted fill, that had been installed, which was deemed to be acceptable for this move. So, as I said in the previous slide, the bridge had failed. It had sunk in the ground conditions. Now, a short while before this bridge was moved, that whole area there was underwater, and you can see some water there anyway, because the weather in November wasn't very pleasant. But a short while before this anyway, the whole area was almost underwater as well. And it's probably one of the reasons why we ended up with the problems we did, because the ground, the water levels there, the ground water level is something that was proven to be problematic as the team were trying to move the structure. So there were many attempts. I won't go through a lot of detail on this. There were many attempts to move the structure. There were alternative methods which proved to be not successful. Putting things underneath the wheels of the SPMTs to see if that would kind of get the momentum going with the SPMT vehicles, but many failed attempts, which then, as you can imagine, was then delaying the handback of the track, which was the ultimate target, delaying the handback of the track, because obviously we couldn't handback the track with the structure back in position, and then the track, OLE and signalling stuff being put back on the structure once it was back in position. So there were many attempts to move the structure, many failed attempts to move the structure, but eventually, obviously, the bridge did get moved in position. Now, one of the issues that was around the structure was the fact that in this photograph here, and the picture you can see on the left-hand side of the slide at the bottom, is there was quite a significant issue with the buried surfaces that were in the roadway, and that was a key factor in terms of how the roadway could be built, how those cables needed to be protected, because these weren't necessarily cables that were serving the railway. These were cables that were serving the industrial estate that this site sits within, and there's some quite key companies which operate in those, including Rolls-Royce, which we couldn't afford to damage any of those cables. So there was a key piece of work in making sure that those cables were protected when this structure effectively was driven over the top of them. And as you can imagine, the thing that what I showed you in that previous slide with the temporary works that were kind of being suggested as temporary measures, these had to be really carefully designed over those cables, which is what you can kind of see in some of these photographs on these slides. So I'm going to move on from that, and then eventually we had to get to a point where the structure was driven into position, and eventually got there by actually doing what should have been done in the design. So the design, the key thing about the design and the roadway of in the design was that the fact that the design suggested that there should be a tarmac roadway built, such that the SPMTs could drive over that tarmac roadway. And what you'll see through the next few slides is that tarmac roadway wasn't installed. A decision was taken not to install the tarmac roadway, and it had a major detrimental impact on the program, which we'll come to. So there was an investigation into the fact that this job overran by a few weeks, and there was a remit for the investigation. So it was broken into 4 parts. There was one part was the development and design structures. There was a small team of people that were set up to make sure to investigate whether we'd actually got the development design right. There was another team of people set up, of which some people are on this call now, to talk about the management of the construction on site. Another team to talk about the roles and responsibilities of the Network Rail engineer and project management team that were on site during the works, plus the people like myself that were parachuted in to kind of, we think we are helping, but there is also a view is that some of the people, maybe like myself, that were brought in perhaps were a little bit of a hindrance, and just by throwing resources at the job didn't necessarily always become a help. And there was another team brought in to look at the management during the crisis and how we responded and then recovered from that. So the key findings of the investigation is that the method of construction adopted and the design that was selected was correct for Gypsy Patch. It wasn't a first of type. These jobs are done a lot all over the country and all over the world. So it was deemed to be the correct method of construction. There was a lot of experience in the team from both the contractor and the Network Rail team, done many of these jobs before, but it was the heaviest SPMT bridge move in the UK at that point in time, and it was significantly greater than anything that the team had done before. Now, I've touched on this in one of the previous slides, is the root cause of failure was the fact that there was a design that said the roadway should be constructed to carry the SPMTs, which are carrying this structure, which is about 5,000 tons in weight. And the kind of root cause of failure was the fact that that wasn't constructed, and a decision was taken not to do that, and I'll cover that in a later slide. And then that decision resulted in some integration issues between designers and the management of the risks between the designers, because there was more than one designer, and the principal contractor on this job. And Network Rail were the principal designer, and what was found through one of the findings through the investigation was the fact that Network Rail hadn't fulfilled its duties and the CDM as the principal designer, certainly hadn't discharged all their role and responsibilities. And the risk contingency kind of pre-reviews that happened, I talked about the complexity of the job earlier on. The risk and contingency reviews that were held didn't necessarily reflect, probably looked quite a lot at the bridge itself, but then didn't necessarily reflect how complex the kind of everything that was on top of the structure was, and the go-no process didn't really talk about a lot of that. So the engineering lessons learned, so it was the correct single option. The fact that it was a reinforced concrete structure that was built on site was kind of, as I said in the previous slide, it was the right thing to do. There was lots of other options considered, but this was the preferred single option. And the process that was followed for that option development was good. And yes, there were other options, but they were discounted. And all this slide really talks about is the fact that the option selection process had been followed and it was the correct option. But the problem is the issues that caused the failure were the fact that the design was not then followed. Talked about SPMTs and the fact it was the heaviest bridge at that time. It was the heaviest, but it was proven technology, proven method of working, and the industry guidance on the weight of the structure again was followed, and our engineering team and the design team were involved in that decision. And as I said, it was the right decision, and a lot of the engineering integration and buildability work particularly for the structure had happened. But as I touched on earlier on, probably there's other work, well, not probably, definitely there was other work that could have been done in terms of understanding how much more complex the work and how detailed. One of the things I picked up on is how detailed the timings were for some of the tasks that I'll come to talk about in a second were in the detailed plan. So I'm not going to cover all of this stuff on the slide because it'll take me a long time to go through it, but there were some things that through the construction, perhaps again, as I talked about with the complexity, may have been overlooked. So the McAloy bars, you know, that was almost precision kind of technology to actually install that bridge with those McAloy bars. Having watched that actually be undertaken, You know, you're talking millimeters. This 5,000 ton structure has to be positioned within millimeters of its final position, because these macrolide bars were planned with absolute precision. And the L-shaped precast, I've got a photograph of these later on. It did cause us some problems. Once the bridge structure was in place, the placement of these L-shaped parapet units caused us a few issues and delays through the kind of the extra work that had to happen on top. The overhead line foundation caused us some concerns, and the interface with the suspended cables, which you'll see, the backfilling on top of the polyester blocks, polystyrene blocks. That is an activity that I think should have been more meticulously planned in terms of how long each of those blocks would take, how long then the backfilling would take. Again, it needed military precision timing, because it was key in that the amount of time that it took to backfill certainly caused us some concern in the latter activities. Talked about the SPMTs a lot. Yes, there's probably nothing else for me to cover on that slide. This slide, the only reason I've left this slide in was just to show, and I'm going to touch on this later on, I'm hoping you can see my cursor moving on the screen now, is this area here is something we're going to talk about later on. And this area here was backfilled to quite an extent, some with polystyrene blocks, and then the rest with motorway type fill. And I'll come on to it on some later slides as to why, again, a subjective topic, but I'd like, because I've seen some of the people that were on this call, some of which have got more experience than I have as well, in terms of positioning of P-way asset, and we'll come to one of those points later on. So this just shows kind of the fact that, yes, this has been done before. It wasn't a first of type. So yeah, these are another company's. I think most of these are another company's SPMTs, but it just shows that this wasn't the first of type. Some of those structures not quite as heavy as Gypsy Patch, but certainly getting up towards, particularly that one on the bottom left, that's about 1,000 ton lighter. So it is lighter, but obviously the heavier the structure, the more SPMTs you need to actually move it. And you can probably see in there that they have got steel sheeting on some of that structure there, which is one of the features we'll talk about on the next slide. So this was, as I said, root cause issue. If you look at what's on the screen here, what this talks about is what should have been installed, such that the bridge could have been driven like you would drive your car over. You drive these SPMTs, that was the design. It was designed to be some compacted layers of type 1 fill, and then topped off with 100 mil of tarmac, basically. A decision was taken, and we'll probably cover this on the next slide, not to do that. And that, as I said, through the investigation that happened, that was deemed to be the root cause of the issue. Now, what I said in my earlier slides, and it's probably not, and I know it's not covered in these next slides, if this job had happened in the spring and there had been less water around, then we will never know as to whether we would have got away with this or not. Because if you tried to drive the SPMTs over the type 1 fill, compacted fill, that's not got a lot of water in it, we might have got away with it. Like, as I said, if you try and drive your car over type 1 fill, which isn't wet, we sometimes can get away with it. But if it's been raining for a couple of days and you try and drive your car over it, you might not get away with it. So this was that I've left that slide in just to show that that was the design. And that's, as I say, what happened is the wheels were getting bogged down, and what was happening is those wheels, you can see in the picture, were spinning, and then the act of the spinning and the axles moving around caused some of those actual axles to shear and were damaged. So whilst the surface was kind of recently laid, the issue was that the material had been had the ingress of water, and it was having an impact on the on the wheels, and then it was causing water to pond around the wheels. Yeah, hence oops, sorry, that's come onto my screen. Sorry, I didn't mean for that to happen. Hence it getting stuck. So I've probably covered some of this stuff that I was going to talk about anyway. Yeah, so I think I've covered everything that was in that slide. So without any sheeting or any tarmac, you can see why. Yeah, I guess you can see from that photograph anyway why it ended up getting stuck, and it ended up causing us to have a plan that was then under stress. So this slide here again shows the structure in its final position, but what you can see there is you can see that the fact that there was well, you can't actually see it from the photograph, but what I know is the fact that a tarmac roadway had been installed such that the structure could be driven into its final position. Now, one of the things about this slide and this diagram on the left-hand side is one of the other things that causes an issue in the backfill activity is there was some steps built into the embankment there, which would then aid the installation of the backfill and the polyester blocks. But there were some issues with which caused some more time delay in the setting out of those steps. So anyway, it ended up causing another load of trimming required. And whilst then we were on the critical path. So once the structure was in position, we were absolutely on a critical path for backfilling. And then once the backfilling was complete, we were then on a critical path with the installation of the bottom stone on the structure. And then for the OLE signalling and track work was absolutely on the critical path because we'd made a commitment to the operators in terms of this work going back into operation such that our customers could then use it again. So I'm not going to cover all the things on this slide other than, and you can feel free to read it when these slides are sent out, but there were some decisions made, as I've talked about, which were not as per design. We talked about Network Rail not fulfilling their duties as principal designer, and we talked about the two things I've highlighted in red there. The roadway was a potential single point of failure, and as we know, the roadway did then become that single point of failure, did end up failing, and was the one reason you could pick up as the fact that we overran by a couple of weeks. And as I've said a couple of times, we will never know if this work had happened as per the plan. If it wasn't for COVID, we might not even be talking about this on this call now, other than the positives about lifting a 5,000-ton bridge with the SPMTs and how successful it was, rather than talking about it probably because because the job overran. And again, through this, again, not going to talk about this much. It's some of the detail in there I've highlighted in red. There is suggestion that there was a commercial decision about not building the roadway because the installation of the Type 1 fill deemed to be acceptable, not putting the tarmac surface on deemed to be acceptable, but that ultimately proved to be the wrong decision. And there are suggestions that it wasn't accepted by Network Rail. Network Rail weren't consulted in that decision. But one thing I will say on that is we did have Network Rail people on site. So whilst Network Rail people weren't consulted in the decision, we had Network Rail people on site that knew the decision had been taken because we knew we were moving the bridge without the tarmac service having been installed. And you can see the point I've highlighted in red there. There was no single drive in mind for the risk in the decision. It was about the discharging of the CDM role of principal designer, principal contractor, designer, and all the other roles, the client role even. You could argue it's the whole CDM piece needs looking at for this job, and it was certainly a feature of the investigation that was held. So the recommendations that came out of this, now this is a very, very busy slide, but it's basically asking the five why questions. So why did we have a 16-day overrun? Gypsy Patch, well, because the SPMT wheels sank. and the new bridge got stuck. Well, why was that? Because the principal contractor did not install the surfacing or surface water mitigation as per the temporary work design. But why was that? Because the principal contractor didn't discharge their responsibilities by controlling this. Well, why was that? Because there was no single drive in mind in design and construction risk management. And why was that? Because the principal designer in Network Rail didn't robustly discharge their duties under CDM. This is a very useful slide. And again, I'm not going to go through it in absolute detail because it's a very, very busy slide. But it's a very, very useful slide when you talk about lessons learned. And I'd certainly recommend it kind of being used for any job. So any job that goes wrong in future, because it certainly helps when you're trying to, even if I just talk through this one slide today, it probably would have helped you go away with an understanding of what happened at Gypsy Patch Bridge. So a summary of the recommendations, I'm not going to read through all of these. So yeah, we talked about Network Rail needing to be better at risk assessment. We need to make sure we don't underestimate the complexity of everything else, because yes, it was a very big structure, but I could argue it's a very big structure, and me as a kind of track specialist for 34 years, I could look at that and say, well, that wasn't as complex as everything else that had to happen, because it was just a big lump of concrete that had to be moved from one position to another, which had been done before. So we need to make sure that we're picking up the complexity of everything, not just the structure itself. Talked about that in the second point, actually. Making sure that the people who are actually appointed under CDM 2015 are actually capable and competent. Now, this is not just about principal designer. This is about the role of the client, the role of the principal contractor, and anybody else who fulfills another role under CDM. Do I need to talk about anything else on that slide? There's a lot about competence in there. There's a lot about contingency management. And certainly the reviews that happened for this site focused a lot, as I said, on moving the structure. And it would be unfair of me to say it didn't focus on everything else, because there was obviously a plan for everything else as well. That's the signalling, the track, the OLE works. But they were probably treated to a lesser extent than the structure itself. So I guess one of the reasons for being on here, and I guess I touched on this in the earlier slide, and I'm happy to open up if people want to come off mute now, if that's an option on this. So in terms of spotting the complexities, so I've talked about the fact this track is signalling, it's OLE. Does anybody who wasn't involved in the job want to tell me about the obvious additional complexity about this photograph? So if nobody does, then I'm happy to, or if somebody who's on the project wants to tell me what I'm focusing on in the center of that photograph. Okay, we have a shy audience, so I'll tell you, this is yeah. So Phil, thank you, Phil. You've just put in the chat there. Yes, this is a modular S&C site. So we in Track installed this site probably about 8 years before. And yes, okay, so it's modular S&C. So what? But I'm not sure, because I just don't know. But I'm guessing, making a quite an educated guess, is we haven't often removed and reinstated modular S&C before in this country. Certainly with the teams that we're doing now, we do a lot of installation, but we don't do a lot of removal and installation. And the other complexities, obviously, this is that route. Sorry about that. This slide here, obviously, that they're taken almost from the same position. Those photographs, slightly off, slightly back towards the other way. But yeah, you can see that this is a modular S&C site. It's got OLE structures on the structure, which had to be removed and reinstated. On the photograph I'm going to show you in a second, that what you can't see in that photograph is there is cables running down both the up and down side. Significant number of cables that had they need to be well, they couldn't be disconnected, so we had to work around those cables. So you can imagine removing that existing structure, installing a new structure with those cables still in place was one of the additional complexities. So this wasn't an easy site. So this photograph here shows, it shows the depth of the excavation. So you can see that that forklift that's in the photograph on the left. So you can scale that for yourself as how deep that excavation was. The photograph on the right-hand side is after the polystyrene blocks have been backfilled. So underneath that, now I'm sure Brunel will be turning his grave, but I'm sure other people who use these blocks a lot are confident there's polystyrene blocks that are underneath this for a few meters. That are then backfilled with type 1 fill, and then there was a progressive assurance of backfilling all the way to the top of that structure before you then get to bottom ballast level, and then bottom ballast comes in later on. And I've just seen a question that's gone into the chat, so I would just as well answer that now. So I didn't see who asked the question. So modular S&C, for those who don't know. So this is S&C here, and what you can see here is a metal shroud. So what this allows us to do, now it was ultimately, back many years ago, it was designed such that S&C works could be delivered in short possessions. Now, whilst we don't do a lot of S&C delivery in short possessions, it does allow us to build, to stage S&C delivery, because the S&C bearers, what would have been in the past a long bearer that stretches all the way from the left-hand side of that, you can see there, all the way across to the right, there's a split in the bearer, so there's a separate bearer there underneath this shroud that's then bolted together, shroud on top, bolted together, such that it does the same job as what a long bearer would have done before. So hopefully that helps answer the question. Right, so back to this photograph, and yeah, so you'll see in a moment why I then get a little bit concerned, which is why I'd like to open up a chat, if we can, about whether my concerns are well placed or whether my concerns are not really a concern. But as you can see from these two photographs here, in the background of that photograph, there's also a lot of S&C. And one of the things I do want to discuss as well is on the next couple of slides. So it's not S&C we had to take out, but it's certainly the S&C we installed as part of the Patchway Junction S&C about 8 years prior. So it was the depth of S&C, position of the S&C we're going to replace, or sorry, reinstate, and then the position of that S&C that exists in the background to that picture. So I promise I'm getting towards the end of the slide. So this was the other side of the structure, actually. This was the backfilling activity. So it was done in layers. Again, to save time, we were able, through the progressive assurance, to actually take some time out of the backfilling by increasing the depth of the layers that were backfilled. Because if we hadn't done that, we'd have overrun, because there was a few of us who were on site watching this activity happen, and we would have taken a lot more time. Now, if it was the right thing to do, and the testing that was happening at the time proved that we had to continue it, which what I believe was the 100mm layers, then we would have carried on doing in 100mm layers. But we were able to reduce the amount of layers, reducing the amount of time, such that we could meet the critical path that was in place. And thanks, Mick, for your comments on the additional comments you put. I didn't see what they were, but I see you've put a comment because I haven't read it yet. So this was one of the additional complexities. So you saw it in the previous slide. We were working around these cables. Okay, it wasn't a concern for most of the time because they were suspended up in the air and didn't really get in the way until we started moving the bridge into position. So there was a concern when the bridge was being moved into its final position with the location of these, and I know some of the network rail team that were on site here had to ratchet the cables up further than they were initially ratcheted up because of the structure's concerns. The structure wasn't going to fit underneath. And then the next photograph is a photograph I took, which shows, again, it was probably a little bit of an oversight, because actually installing those L-shaped parapet units was quite difficult, and it took a lot of time. This was in effect on the critical path, because this had to kind of happen in conjunction with the OLE works and the track works when we were really up against it in terms of time. Now, this next slide I don't expect you to be able to read that. All it's showing is what I was kind of showing you in the background of one of the previous pictures. Now, what I've put on the top of that slide, and this is by no means a criticism of anyone who was involved in the project, because some would argue it's the right thing to do. I may argue, in my subjective mind, that why? So why did our design? Because we were only removing a very, very small part of this layout. And one of the things we ended up doing, as part of the mitigation for time, was working with the contractor and working with one of the project engineers who I got in independently, who I'd worked with for many, many years, got him to come and give me an independent view as the right thing to do in terms of whether we could get away with reducing the amount of tamping that was involved. Now, obviously, we had to tamp the work that we'd taken out and reinstalled. But my concern was we didn't really have enough time to tamp the whole layout. And my view, my subjective view, which I'm happy to open up a conversation on, is why would we have been tamping that? Why couldn't we have designed it such that we didn't have to tamp into that whole layout? And I saw that Mark Smith actually is on the call. He may want to comment on that in a second, or even Alex. I know Alex is on the call as well. So those two individuals who may want to add a comment to that. But equally, anyone else who wants to maybe disagree with me that actually the right thing to do when you're taking one part of this junction out is tamp the whole layout. I've got an argument that says if it ain't broke, don't fix it. But equally, we could correct some wrongs by perhaps designing through the whole layout as well. And then the other kind of subjective, so this one here, and I've got to be fair on this one, I was really, really worried. So I was concerned. I didn't know anything about this job until the day that I was asked to come and have a look at it. So immediately I start asking questions. Immediately I find out that it's modular S&C on top of a structure. We've got OLE structures to put in as well. We've got suspended cables. It's a pretty complex job. Now, my immediate concern when I was told we've got a second tier PWA contractor on this, I was going to be concerned. Of course I was. But what I will say though is the individuals that, and it could be by chance, but the individuals who were employed by the second tier contractor here, and I'll say it was KGJ Price, the individuals had a lot of experience in installing modular S&C. Now, we could have ended up with a second tier contractor on this that actually wasn't experienced in installing modular S&C, wasn't actually experienced in complex S&C renewals. So Mark and Neil from KGJ Price did a fantastic job of not only replanning it once, probably we ended up replanning it about half a dozen times because the bridge kept getting stuck. And the bridge, what I didn't say earlier on, we moved the bridge one way and then we had to move it back and then move it again. So because of that, we had to keep replanning the work, keep finding time from somewhere. So that the contractor, whilst I was concerned it was a second tier supplier, they did a fantastic job, as did the OLE contractor as well in PodTrack, did a fantastic job and actually working as an integrated team, and probably ended up having to be even more integrated than they were already, because we had to put more overlap in the tasks, and the team worked really well together. But I was concerned because we had a second tier contractor on a very, very complex piece of work. I think Mark's just put it was version 16 of the plan, so I've underestimated that slightly, so thank you, Mark. So I talked about this earlier on. There probably was multidisciplinary review, of course there was, because it was a multidisciplinary job, but we perhaps as Network Rail, as capital delivery, we should have included, and we've got to learn the lesson from this, and I certainly can quote some examples very, very recently where we still haven't learned the lessons in this. So we need to involve each other when we're talking about each other's disciplines, especially when they're multidisciplinary and they're complex. And also, I've talked about this one already as well, is why were we tamping the whole layout? Because I could suggest, like I've said subjectively, that we didn't need to, and we shouldn't have anyway, because we're disturbing something that didn't need disturbing. And this one, I'm not sure I picked it up on the photograph, so I will go. I'm just going to come back to a photograph a sec, what you'll see in this photograph, which is one thing I meant to mention when I had the slide up. Oops, sorry, too far. Right. What you can see there, and this is what I wanted, again, a subjective conversation on, is you can see the location of that crossing there. And if I just go back one slide, what is directly underneath that crossing is gone there. Is on the next slide after it. What's directly underneath the crossing is basically that. So the crossing sits probably just to the left of where that roller is, albeit obviously a few more feet up in the air. So one of the conversations I was hoping to have on here, because I've almost finished presenting now, was that considered? Is it a concern? Is it me just being over concerned? So these things I've put on there as the 4 points. It's kind of this third and fourth points, because we are a track community here, most of us, is that, am I right to be concerned? Am I not? Am I over concerned? And Gilles, I guess that's where I kind of wanted to open up after I've made my last point about safety. And I'll be very, very high level here. And I'm quite proud of this, actually. For those of us who work in the kind of railway industry on track, I'm quite proud of how safe we are. And all I'll say from a high level is that what I saw in the high street environment, which is where this principal contractor is perhaps used to working, what I saw was different. And I won't say any more than that, because it would be unfair of me to say more than that. But the fact is, I'm really, really proud of what we do in the railway community in terms of safety. We're still not perfect. I absolutely know that. But I'm proud of how we do it. And I'd say there's the high street environment perhaps has some things to learn from us, particularly in things like communication between machine and machine controller on the ground. And I'll leave it there, because it's quite again, it could be me again being very subjective, but it's certainly a lot to learn, I think, from high street to railway environment. So Gilles, I think that's almost my presentation done, because I've touched on some of this now already, and I'm happy to take questions or maybe get some views from the experienced audience that we've got on here about some of those things I talked about. And I'd also be happy to hear from the likes of Mark and Alex and others who were involved, and maybe challenge me on some of the things I've said. So I'm presentation done, Gilles, and I'm happy to unshare my screen now.
Yeah, brilliant. Thank you very much, Brian. Okay, so let's open to the floor. So anybody wants to come in? There've been a lot already of comments and questions in the chat. I'm not too sure which one to start with. So who wants to come in first?
I'm happy to have a discussion or whatever about the tamping limits and some other things if you want. I'm Alex Sinkovich. I was the DPE for the scheme and the track engineer for it for Network Rail. So for the tamping limits, I'd agree entirely with Brian. It was frustrating how that design came about. And actually, without going into too much details, there's commercial arguments back and forth about the extent of the tamping going on at the moment. So as part of my review of that was basically my only comment on the design, is why are we tamping so much? I actually even suggested a way you can tweak the thing, you can change some of the alignment through it, you can actually reduce it significantly. And again, you know, I think everyone has good intentions. The designer for it was reluctant to change anything. And I think it probably goes back to part of the integration piece. This is you know, the main contractor is a civils contractor. It's their subcontractor doing the design. So I'm suggesting, I think you need to change this. You can reduce the tamping. Oh no, we don't want to. We think it's fine. And that wasn't really adequately assessed in terms of the time it would take. Because I think at the time the design came out, the likes of you know, Mark and Neil weren't necessarily involved. from KGJ Price because they're a subcontractor. So discussions around the track design happened, and I'd like to, without being too harsh, kind of slightly fell on deaf ears. Those, we need to reduce this, the limits can be reduced. And I think it's part of the problem we have when you're dealing with subcontractors. You're going through your main contractor and it's not their core business, so they're perhaps less interested in those bits. It was very, very focused on the bridge, so some of the track elements were, oh well, we can deal with that later. So yeah, I absolutely share Brian's view. I think we absolutely could have reduced it down, and I mean, feel free to correct me if I'm misremembering even Neil or Mark, but I'm pretty sure we had some sort of informal discussions to say, if you can reduce that down, actually when you get to it, please, you know, do reduce it as much as you can do for that reason, that it doesn't look excessive.
Yeah, so Alex, just to respond before anyone else comes in. So I think there's two things with that. One is just the risk of anything could happen once we start tamping a layer which doesn't need tamping. But for me, we're all under so much pressure in terms of cost now as well. We really need to start looking at making sure we're looking at cost versus value, because the cost of us doing that could have been significant, but also the value, what value would we also going to add by tamping that whole layout?
Yeah, no, agreed. And that said, I won't go into it, but there are commercial implications coming about now and the back and forth about whether that was in the original contract, whether it wasn't. Now, my argument would be it's a design and build. We've advised them to reduce it as much as possible, and they chose to ignore our advice. I won't go into any more than that on a public forum, but it was frustrating, and absolutely, I share your view that as an industry, we can't just be jumping straight to the sort of default option of, oh, well, we'll tamp everything because that's sort of compliant and nice and lovely, when actually in practical terms, it's not what's needed. One other little point I would make as well, slightly off the tamping bit with relation to using the second tier contractor. Again, we had concerns with that, and just like to say, we got KGJ pricing very early and had some good conversations with them, which reassured us from the off. So we were concerned, but having spoke to them right up front, it was you know, no more issues.
Thank you, Alex. Are there any more questions? Please put your name in the chat if you'd like to come in.
I would be interested, Giles, in if anyone's got a view, because there's lots of experience on this call, about my comment about the position of the crossing over the, well, firstly in proximity to the structure itself anyway, but then in terms of over that very, very deep backfilled section. I'd just be interested if anyone has got a view on that, whether I'm just overly concerned.
Can I make a comment on that? It's Phil Ransomere.
Hi, Phil.
Hi. I was just trying to type something, so I might as well say it. I agree with you. The obviously the crossings of discontinuity is going to be an impact point, so it's not the normal loading from the track. It's an impact loading. You know, if it were a jointed layout, we would strive to keep the joints away from the structure. So clearly, it's something that needs to be considered. It's a very good point. I'm sure it can be engineered such that it is suitable, and I'm sure it'll work. I mean, I think once the thing consolidates and settles down, I don't suppose you'll have any particular problem. But the reality is, any infill, any structure where you start cutting the earthwork and reinstating it, you know, we all know that for years to come we end up with settlements and problems in those areas. You end up with slacks on the approach to under bridges for years to come. So, you know, obviously every effort's being made to design and engineer that issue out, and it is a good challenge to say, did somebody actually notice there was a crossing there, a high-speed connection, you know, high-speed turnout or high-speed crossover, and did they take extra account of that when they're developing that design?
Thanks, Phil.
Thank you, Phil. Paul Robinson, would you like to come in?
Sorry, I was on mute then. Hello, Gilles. I'll just put in the chat a question about the at the top of this show. You mentioned that the bridge failed, and I just wondered if that was specifically in relation to the movement when the SPMT wheel sank, or was there actually any structural damage that you had to repair as well?
No, there was nothing significant when the bridge failed, because there was a concern about that. There was a concern that you could effectively break the back of the bridge if it settled in different places. But no, there was no major concerns with any damage to the structure when the bridge did start sinking. When I say sinking, that probably sounds like it's overplayed slightly, but it only had to sink by a very, very small amount with that significant load on top of the SPMTs. The damage, actually, what took the brunt of the damage was actually the axles of the SPMTs, which is one of the reasons, apart from the sinking in the formation. It was one of the reasons why the SPMTs couldn't then move, because there was the damaged axle. So some of those SPMT units had to be replaced before the bridge could be moved into its final position. So yeah, there was no damage to the structure, and we did have some aerial surveys done of it whilst the structure was sat waiting for the spare SPMTs to arrive.
Okay, thanks. So that was some small saving grace then.
Yeah, absolutely, because that would have been absolutely catastrophic.
Thank you, Paul. Mark has just put a comment in the chat, but I think it's an interesting one. Mark says, I think the late involvement of the track contractor is an industry-wide issue. What's your view on this, Brian?
Yeah, as we know in this region, Gilles, ever so well, even since this incident, there has been another incident with another track contractor on another structure, which has given us cause for concern. So absolutely, I'm with Mark there. Is that okay? I know we do go down the road of second tier suppliers. Now that I don't like that expression, but that's just the nature of what it is. The second tier supplier, I think that absolutely has to be earlier engagement between the likes of Alex as the DPE and the second tier contractor, and not do it all via the first tier contractor. We've got to be better at that, because what it proved when we came to the job itself is that absolute direct conversations about the plan and direct conversations about the design and direct conversations without having to go through the civils contractor probably saved a lot of time, a lot of confusion, a lot of effort, and ultimately I think it gave us the confidence. If we were doing that conversation via a contractor that doesn't necessarily understand the track discipline, I don't think we would have handed back when we did. But I think the fact that we broke the link helped, and I'd be comfortable with Mark's feedback on that as well, because certainly Mark and I were talking quite a number of times every day to kind of give ourselves a plan that worked.
I'd agree with that. I mean, you know, the civils contractor got their head buried in trying to get the bridge out. You know, they couldn't see more than you know what was in front of them. So it definitely worked better to just leave myself with the support of you to you know, to reprogram and to bring the other disciplines in as well. I think it took a lot of pressure off the principal contract and let them do what they are good at, and leave us to do what we're good at.
Yeah, thanks, Mark. And yeah, you, as I said in the presentation, your guys did a great job of not just replanning, but replanning a whole load of times, but also it was the impact that it had on your other work that was planned, because this wasn't just overrunning by a couple of hours, this was overrunning by 2 weeks. But it wasn't just overrunning by 2 weeks, it was going to overrun by a week, then 10 days, and 11 days, and ultimately the 16 days. So no, your team did a great job, as did Podtrack, in kind of sticking to a plan. Once we got to where we could take control, it kind of went like clockwork. But I guess one of the differences that I saw at the time between a track plan and a civils plan is the hour by hour planning we do in track world is not necessarily the detail that exists in this world that I saw. And I know that's a very isolated issue, on this one particular site. But the hour-by-hour detailed plan, I didn't really see that was there, particularly on, you and I discussed a number of times, the backfilling activity. I think I know it was underestimated.
Yeah, thank you,
It's
Brian.
a little bit worrying. It's a bit worrying when the track people can see that it's not going to be filled in time, where there's the people who do it day in, day out can't. You know, you can see as it was getting backfilled, the times that was in there really weren't achievable. You don't have to be a bridge building expert to see that you're not going to move X amount of muck in the time that they had.
Yeah,
but I suppose that's down to, on a track renewal, we have 54 hours, 27 hours, things like that, and every 15 minutes is planned, and it's planned for the nearest 15 minutes over a weekend. So you soon get to realise how quickly things happen, and what can, and all the logic between, and what can happen first, and what needs to happen for other activities to happen.
Yeah, absolutely.
Yeah. Thank you, Mark. Sorry, the line is not the greatest there. So we move to Mick. Mick, did you want to ask a question?
Yeah, it was just really Brian's observation really regarding the position of the crossing nose in relation to the bridge, and I suppose I've got a couple of things on that really. And I guess the first point I was going to make, I guess the answer to that is no. Would there have been an opportunity through the design development to move the position of that crossing? Probably not, I guess, when you consider the OLE and everything else that's there, so we were probably fairly constrained. But I guess my question really to if anyone was involved with the project, were sort of stiffness transitions sort of designed in from the edge of the bridge deck for a particular length, maybe sort of 20 meters or so, just to sort of reduce the impact of that crossing nose in relation to the bridge deck.
So I can sort of take that. So yeah, no opportunity to move the crossing at all. It's a very sort of tied together junction there. It would have been you'd have just it just wouldn't work. So yeah, it was, and unfortunately the bridge had to go where the bridge had to go. So it was stuck really with that. But no, certainly in terms of the backfilling, stiffness transitions, yeah, that was sort of key consideration for all the design. So initially, I think at Grip 3 there was a proposal for transition slabs, but they're a pain to install. They're very difficult, and that was sort of designed out at Grip 5 with this sort of layering and proper compaction and testing and monitor of the EPS blocks. So again, that's I think why it was taking so long, was because they were doing it in small layers to get the required stiffness and things like that. And again, it perhaps wasn't planned as well as it should have been. And then in terms of the track design, we have layers of kind of geogrid and there's some blanket replacement and things like that there, just to sort of manage that stiffness across it. But it was looked at, and quite early on, the civils designers effectively showed that you wouldn't need the transition slabs because the stiffness would be managed through their backfilling design.
Brilliant, thanks for that, Alex.
Okay. Are there any more questions for Brian? Please again put your name in the chat if you have. Brian, I'm going to ask a question myself, if that's okay. It's about principal designer. I'd like to know what action we've actually taken within Network Rail to address the issues that were found by the investigations. What have we changed since then?
Yeah, so one of the conversations that's going on is about whether, well, I've got to be careful with this because I've got a different view, which I'm comfortable with, is that the role of the principal designer, there are some of the teams are suggesting that the principal designer role may be better fitted within the supply chain and not within Network Rail. Now, I've got a view, which again I'm comfortable with, is that the principal designer role actually should sit in Network Rail land, because actually it gives healthy tension between principal contractor and principal designer under CDM 2015. Because if you put the principal designer role in with the principal contractor, it could be a little bit too much of marking your own homework. And I think the healthy CDM tension is what's needed in big projects like this. But you do need to make sure that your principal contractor has got the competence to be appointed into that duty holder's role. So the action, Giles, to answer your question, is there's a review as the appropriateness of Network Rail as the principal designer. But it's not a one size fits all, because it might be appropriate on a job like this, which is multidisciplinary and very complex. It might be suitable for the principal designer to be another, not Network Rail. But in my world, I think it's appropriate that I keep the principal designer role within Network Rail.
Okay, thank you, Brian. Paul's got a question in the chat there. Are you able to answer that? So, Paul, I'm going to read it out for you. What sort of stiffness transition was used? A wedge or ladder vitras type, perhaps?
So, sorry, Brian, I can answer this one as best as I can. So, there isn't necessarily a stiffness transition required, because you've got your 300 mil ballast plus over the bridge. So what they did was demonstrate that actually the stiffness is fairly consistent across it. So we have got geogrid and things like that to sort of manage that stiffness on and off. More than anything, though, just to make sure it picks up, if there's any settlement, it's maintained at the same sort of stiffness. But actually, there's not a massive difference between them, because it's not a sort of shallow depth bridge or anything like that. So things like the VTRAS system or kind of granular wedges and things were taken account of within the civils design to make sure that actually it kind of married up with the stiffness over the bridge. Now, I could probably get a better explanation from the civils team, but that's my understanding and how it's been explained to me, that's why nothing additional over and above kind of geogrid really was needed. And I suppose one final thing to that, we did obviously like the standard sort of track monitoring you do after something like this, and there was virtually no movement. Again, I'm sure Mark can comment on that, but I think when they went back in and did their sort of follow-up tamping and things like that, it showed very little sign of movement. The whole thing was absolutely solid, and the track quality's been very good.
I've actually got I did a analysis and a presentation on the settlement of the job, because this job was a bit of a strange situation in the fact that the follow-up tamps weren't booked from the very beginning. When the main possession got moved, the follow-up tamps didn't get moved. So normally on a track renewal, you'll have tamped it after a week or two, and then 6 weeks later. Whereas this one, it went in sort of October time, and we didn't do our first follow-up tamp and speed off tamp until Christmas. And then we didn't tamp it again until another probably 10, 12 weeks later. So it proved it was a good time to do a bit of analysis on how track settles and what happens when you leave a renewal of this type so long without tamping. So I've got some, like I say, presentation on that, and it's got a lot of data in with when we surveyed it, how much it had got off, how quickly it went off, the heights that we tamped it back to, and then where it settled to, etc. So if anybody's interested, I can send that out.
Yeah, certainly I would be, Mark. Yeah, it seems to be quite interesting data that you've got. Okay, I'm just looking at the time now. I think we're coming to the end of our sessions. Try to finish to give you a few minutes back to move to your other meetings. So I just need to thank Brian very much for coming and talk to us about it. In my opinion, we don't do enough lessons learned and share them in the right way. So I think coming into this forum was really hopefully a start to a better way of sharing industry, not only within Network Rail, but within the industry. Thank you, Brian, for this great presentation. And I'm closing this meeting to wishing you all a good rest of the day, and see you in January.
See you, Giles.
Thank you. Bye-bye.